To understand, okay. So as we discussed, like if in this particular system where an object is supposed to be in smooth continuous motion, the polynomial that represents that motion is this, and for t equal to 0, the distance traveled is 0, which means the object has not even started. And let's say the time is in hours and distance s, let's say time t is in hours and distance s is in kilometers, right? Then for t equal to 0, no distance traveled, nothing. The object even didn't started on the first place. Now t equal to 1, it traveled in 1 hour, it traveled 10 kilometers, right? And then at let's say if t equal to 2, now if I put the same expression s equal to ut plus half at square, now if I plot it, I mean if I extrapolate the points, for 0 0, for 1 it becomes 10, and for, so the table will be different. Now t s, for 0 the distance is 0, for 1 hour the distance is 10, and let's say if I'm trying t equal to 2, now t equal to 2, which will become u into, and u we have assumed it to be 5, sorry, u is 5 and a is 10, then what we can say is u times t plus half a times 2 square. And now if I substitute the value of u, which is 5 times 2 plus half into, if I substitute the value of a is 10 into 4. So that will become 10 plus, and if I cancel this, I get 4 5 20, and I get 30 here. So when t equal to 2, this, well, for 2 hours, it travels like 30 kilometers, right? Now this is, and this is how we kind of understood the system. Now when I say system, the system includes the object which is in motion and the distance and the time which has been taken to derive, uh what could be the speed, or like what could be the time for, and how much distance we can travel given the speed is 5. Now I can increase the speed to 10 and can figure out like what was the distance that is going to take in, and based on that I can figure out an optimum, और इसके basis पर मैं एक एक ऐसा सॉल्यूशन निकाल सकता हूँ, एक ऐसा सिस्टम ड्रॉ कर सकता हूँ जिसमें v का एक u का एक स्पेसिफिक वैल्यू हो, a का एक स्पेसिफिक वैल्यू हो, s का और t का एक स्पेसिफिक वैल्यू। a जनरली हम कोई कोई केस में कांस्टेंट भी ले सकते हैं, बट अगर इन सब का वैल्यू मैं डिराइव कर सकता हूँ जिसके बेसिस पे आई वांट द सिस्टम टू बिहेव इन अ सर्टेन वे, इस तरीके से मैं इस सिस्टम को बिहेव करना चाहता हूँ, मैं उस हिसाब से इसके वैल्यूज को चेंज कर सकता हूँ, एंड आई कैन डू दैट बाय लर्निंग polynomials, and polynomial is the way through which we can achieve it. Okay, now with this understanding, let's come to fewer properties of polynomial. And as we already discussed over here, that polynomial is again a subset or is part of algebra only. And we have also derived that algebra has few components, which is a constant and then a variable and a coefficient. And all these will be also applicable to polynomial. Polynomials also. So I'll give you a very simple example here. Now let's say 2x cube plus 4x square plus, let's say 8x cube plus 4x square plus 2x plus 2. Let's say this is one of the polynomial. Then we will discuss about these later, but then here the constant is 2, variable is x, and coefficients. Now this will bring, like, coefficients can be, now the coefficient of x cube is 8, coefficient of x square is 4, and coefficient of x is 2. Okay. Now this is how you can identify the constant, variable, and coefficient in a polynomial. Okay. Now from here, a polynomial has also something. Now before that, we let's go ahead and write some few examples of few more polynomial. And let's say I'm trying to think of another example of a polynomial. Let's say minus x cube plus 4x square plus 7x minus 2. Let's say if I ask you what is the constant, then constant would be minus 2, right? Constant would be minus 2. Then variable is x. Now, when it comes to coefficients, the coefficient of x cube is minus 1. Now, the coefficient of x square is plus 4, and the coefficient of x is 7. Now, how I derived that? Now, here if you see, every polynomial that you are looking here is of some certain order, right? Now, if you look at this polynomial, it has a very specific order, right? An order with which it has an x cube, x square, x, which means the variable x is decreasing. I mean, it was in x cube first, then x square, then x, and then no x at all. Similarly, here also the same thing is happening. It is in decreasing. I'm not taking the name right now because I will introduce to the term, and I'm saying the variable x is decreasing as x cube, then decreasing to x square, then x, and then no variable. Right? And what is that decreasing variable relation, let's say, is called? And that is called the degree of the polynomial, or the degree of the variable, you can also say. Now, when we say x to the power 3 plus x square plus x plus 1, let's say. Now, this polynomial that is represented is of degree 3. Now, degree of a polynomial is the highest power. Okay, I'm sorry. So, what we see here is, now these polynomials are in a decreasing power of x, right? The polynomials are arranged in a decreasing power of x. Now, this is a pattern that you can figure out, and here the x is in a decreasing order. Now, the power of x is decreasing. So, x cube to x square to x, and then no power. Here also, x cube to x square x, and then no. When I say there is nothing x here, there is actually x to the power 0, which is again 1. Here is x to the power 1. So, is it fair to say from the expression that we have seen right now that polynomials can be represented as, now we saw there is a coefficient. Now here also if there is no coefficient, which means the coefficient is 1 plus 1. Here the coefficient is plus 1. Here the coefficient is plus 1, right? So which means, and since here x is of the 0th power, which means the value itself is 1 and hence it is a constant. Now can we say that the polynomials can be represented as an x to the power n plus an minus 1 x to the power n minus 1. Now this a, you can call it as a or you can call it as I'll give you a very specific expression also to this. Now x, just look at the pattern that is changing for x, the power that is changing for x. Now dot dot dot, similarly a n minus 2 x to the power n minus 2, and similarly we can come here to a2 x to the power 2 plus a1 x to the power 1 plus a0 x to the power 0, which goes without saying that it becomes 1, so this becomes the expression of the polynomial. Now here you can also write it as like uh, and I believe there is nothing wrong with it, an plus bn minus 1, then you can write something k x n minus 2. It can be any constant, right? Now dot dot dot, when you say this, let's say p x to the power square plus q x to the power 1 plus something called as d, let's say. Now remember, these are all constant values, okay? These are not variables, these are all constant values. Similarly, a more generalized way of saying it, if let's say an plus an equal to an minus 1 equal to, oh, okay. Now if you have understood, let's say if this particular expression is all clear, now we will like to derive. So every polynomial can be represented in this particular form, and this particular form is captured on the top of the introduction, that when we have started polynomials, this is the form with which every polynomial can be represented, or we can represent every polynomial with this form. So if a polynomial is not following this form, which means it is not a polynomial, okay? uh, Now, for your understanding, not necessarily you have to write a of n, you can also write a, b, c, d, but mind that this should be constant variable. So, which means, let's say from here, from this expression, we can draw certain general concepts, like if a of n equal to a of n minus 1 equal to a of 2 equal to a of 1, let's say dot 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 is here also, which means the similar pattern is getting followed. ये a of n equal to a of n minus 1 equal to, और ऐसे चलते चलते a of 2 equal to a of 1 equal to, अगर ये 1 होता तो पॉलिनोमियल का फॉर्म ऐसा हो जाएगा x n minus 1 plus x n minus 2 dot 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 x square plus x plus a0. Let's say a of n equal to a of n minus 1, a of 2 equal to a of 1 equal to a of 0. और यहाँ पे आने से पहले मैं आपको ये बता दूं कि जब भी लेट्स से अगर एक पॉलिनोमियल का ऑर्डर ये है, तो ये जो पॉलिनोमियल हमने लिखा है, ये कौन सा डिग्री ऑफ पॉलिनोमियल होगा? दिस इज एन n डिग्री पॉलिनोमियल, राइट? वैसे ही जो भी उसका हाईएस्ट पावर होगा x का, पॉलिनोमियल की डिग्री वो हो जाएगी. लेट्स से इस केस में अगर मैं वापस आऊं, तो इस केस में पॉलिनोमियल की डिग्री जो है वो 3 है. इस केस में भी पॉलिनोमियल की डिग्री 3 है. Okay. Coming back to this, if a of n equal to f n minus 1 डॉट 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 ए ऑफ 2 इक्वल टू ए ऑफ 1 इक्वल टू ए ऑफ 0 इक्वल टू 0 हो जाती है, तो ये पूरा एक्सप्रेशन ही 0 हो गया। इसको सब्स्टिट्यूट करें, ए ऑफ n 0 है, x टू द पावर n प्लस ए ऑफ n माइनस 1 0 है, x टू द पावर n माइनस 1 प्लस डॉट 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 0 x स्क्वायर प्लस 0 x प्लस 0, तो ये क्या बन जाएगा 0। एंड नाउ व्हाट वी गॉट अ जीरो पॉलिनोमियल। और एक जीरो पॉलिनोमियल का डिग्री क्या होगा, बिकॉज उसका कोई हाईएस्ट पावर नहीं है, सो डिग्री ऑफ अ जीरो पॉलिनोमियल इज not defined। ओके, इतना क्लियर है हम? ओके, ठीक है। सो फिलहाल हम इसको यहां पे खत्म करेंगे, और हमने एक अच्छी खासी अंडरस्टैंडिंग पॉलिनोमियल्स की क्रिएट कर ली है। इसके रिगार्डिंग कोई भी डाउट हो आप कमेंट थ्रेड में हमें रीच आउट कीजिए, और हम आपका क्वेरी क्लियर करने की कोशिश करें। इफ यू हैव एनी डाउट प्लीज comment on the comment thread, and we'll get in touch with you, and we'll try to clear all your queries in terms of the concept that we have covered today. In our next session we will do few examples and will further proceed on some recitation problems, and then we will in the coming sessions we'll discuss about factor theorem and how factorization is done, and then we will discuss some of the algebraic identities that is generally being used as part of understanding the systems in polynomial. So what we have discussed today, we have discussed like what is algebra, like, and what are variables. First of all, we have revamped the concept of variables. What are the various objects that you see in an algebraic expression, how we are representing variables in an algebraic expression. We have went ahead and figure out that there is some kind of pattern and relationship that also exists in an algebraic expression. हमने पॉलिनोमियल को समझा कि पॉलिनोमियल अलजेब्रा का ही एक पार्ट है। पॉलिनोमियल कैसे लिखे जा सकते हैं, कुछ एग्जांपल्स हमने पॉलिनोमियल के समझे। हमने एक स्क्वायर का एग्जांपल लेकर ये समझा कि पॉलिनोमियल सिस्टम को कैसे अंडरस्टैंड करता है, पॉलिनोमियल हमें कैसे हेल्प करता है टू अंडरस्टैंड एनी पर्टिकुलर सिस्टम। देन वी वेंट अहेड एंड understood another example, a more real-time example of polynomial using an object which is in smooth and continuous motion, which follows the expression ut plus half at square equal to s, which is distance and t is the time, a is acceleration, u is the velocity. And based on that, we have tried to understand for any given value how can we determine the behavior of the system. Consider that time is a variable, and similar we can do for others, but in this case we have considered time as a variable, and how we are determining the distance based on the time, assuming that velocity and accelerations are constant or given. Now based on that understanding, we went ahead and we tried to figure out the various components of polynomial, which is again a constant, a variable, and a coefficient. We try to understand the degree of the polynomial. हमने degree polynomial की degree किसे कहते हैं वो समझने की कोशिश की है. Then we understood how polynomials are represented. पहले हमने दो examples दिए और फिर वहां से एक pattern derive करने की कोशिश की, and we came to the conclusion of the general definition of polynomials and how it is represented. We try to figure out two expression by generalizing the coefficients of the general expression, and we figured out and we get to know that what is a zero polynomial. And we also discussed that the degree of a zero polynomial is not if. These are the things that we have discussed today. In the next session, we'll go ahead and do some examples, and then we will understand what is factorization and factor theorem, and we will also understand some of the algebraic expressions that are required for understanding polynomials and also is needed for understanding real-time use cases in polynomials. And these expressions are these identities are the core of polynomial and understanding polynomial or solving polynomials, right? Uh, any issues or any doubt, reach out to us on the comment threads and we'll get back to you. Thank you for watching and have a nice day.